For this graphing calculator tutorial, we'll learn how to graph and understand the greatest integer or floor function. The definition is, and notice the use of these unusual brackets, f of x is the greatest integer less than or equal to x. So let's try to understand this function. What I've done is I've just written a few examples here. I'll slide up just a little bit of the greatest integer of different values. So 3.14, 6, 0.5, 0, etc. And we're trying to determine, how actually do we evaluate these x values based on the definition of this function? Well, let's start with the number line. So you notice I have a number line with just integers on the number line, and then I put red dots at the various values of x. So let's take a look at 3.14. What would be the largest integer that's less than or equal to x? So if x is 3.14, the integer that's just less than it, so basically just kind of to the left of it, would be 3, right? And this would apply for any values, within this range from 3 to 4. So, 3.1, the greatest integer would be 3. 3.9, the greatest integer would be 3. Okay, but what happens actually at 3 and at 4? Well, the greatest integer of 3 itself, by the definition, it has to be less than or equal to x, so the or equal counts. So the greatest integer less than or equal to 3 is just 3. It's itself. So the greatest integer of some value of x for 3, and then any value basically up to 4 but not including 4, so that would be like 3.99999, they would all have a value, an output of 3. Then the greatest integer of 4 would actually be 4, and then anything to the right of 4 but just up to 5, not including, would have a greatest integer of 4 as well. So you notice what we'll see, like the greatest integer of 6 is 6. The greatest integer of 0.5 would be what's to the left of it, that must be 0. The greatest integer of 0 is itself. What about negative values? So the greatest integer of negative 2.3, it would roughly be about here. It has to be an integer that's less than or equal to that value. So I have to move to the left again, so it would be negative 3. The greatest integer of negative 5.5 would be negative 6. And the greatest integer of negative 6 would be negative 6. Okay, so you kind of get this idea. So really on any interval, we include the left endpoint, but not the right. Right, and then here we would include the left input at endpoint, but not the right. So if I were to draw the next one, it would look like a square bracket here at 4, and then if I'd have to do a round bracket at 5, and then everything in between. All right, well, how do we graph this then, this function? Okay, well, in your calculator, the first step is to go to Y1. All right, just press Y equals menu. And then you're going to press Math, Num, and choose 5, or greatest integer. So in the Math menu, you have to use your right arrow over to go to Num. That will paste INT with a left bracket in there, and you have to type in the X. And let's just choose this window. All right, and then you see what the output. So your calculator provides, it shows that it's this type of step function, right, that we discussed in the section 2.2 material. However, it doesn't show what happens at the endpoints. So we have to do some delving in, which is what we did up here, and we determined that for each interval of x values, right, the left endpoint is included, but the right endpoint is not. So when we kind of take this graph and I graph it, but now I'm including the left endpoint and not the right endpoint, this is really what our graph, a more accurate representation of the graph would look like. And these steps, they continue indefinitely. So for our example, if I was at 3.14, I should be on, the greatest integer should be 3, right? At 3, the greatest integer should be 3. So it includes that 3. But if I go to, let's say 2, for example, right? Or let's just say 2.99, the greatest integer would be 2, because it has to be to the left of it. All right, so you get this example, so this idea. So there's a jump really at these integers. However, it's defined to be 3, right? The greatest integer of 3 is 3, but if I'm at 2.999, the greatest integer is 2. So hopefully you kind of see this idea. It'll be further discussed in the section 2.2 guided worksheet.